Hi class, today is Mexico's Independence Day, Dia de la Independencia, so that's why I'm wearing this. Anyhow, let's get back to physics. Now, first of all, I don't agree with this question, and what I mean is, although it comes up with the material that we have been talking about, this is truly a free fall question, and we haven't learned free fall. It's still a uniform acceleration question, but I think it'll be easier for me to explain it with free fall. But there's nothing I can do about it, so I'm going to explain it using the topics and information we have learned so far, using uniform acceleration models. So let's get right to it. It says, while repairing a defective radio transmitter located 410 meters up on the skydeck of Chicago's Sears Tower, Nelson Aguilar drops a hammer, just like he dropped footballs with the Eagles. Nothing against Nelly. That falls all the way to the ground below. How long will it take for Nelly's hammer to fall? With what velocity will it hit the ground? So on the first question, we see we need to find time. How long will it take? We want to find time, right? And second one, with what velocity? So velocity. Remember, we always start with the drawing. So I'm just going to represent the hammer with this dot. Now it's falling down. Free fall. So it's going down. Let's do a vector which points downwards. And we know the reason why it's falling is gravity. So we have gravity. Oh, let's redo that. Have gravity, which points down all the time. And although I should use y because we're on the y-axis, I'm going to use x just because it will make more sense for our equations for uniform acceleration. Okay, so our initial position is over here. We're going to call that 0 meters. This is the starting point because it's falling from rest, right? It's at rest. And at the end, the final point or final position, it's 410 meters, just because it's the height is 410, so 410 meters. We know that delta x, change in x, is x final minus x initial. So we can say that delta x is 410 minus 0, which is simply 410 meters. And we also know that gravity has a value of 9.8 meters per second squared here on planet Earth. So when we write our given, oh, one more thing I forgot to add to the drawing. So if it's at rest before it falls, we know that the initial velocity is 0 meters per second. So given, we have the delta x, 410 meters, acceleration due to gravity, so I'm just going to do a sub g, 9.8 meters per second squared. We want to find time. How long will it take? Time. And we also have initial velocity because it's falling from rest, so it's at rest, 0 meters per second. So now you have to decide, or we have to decide, which equation it's going to help us. So basically the first thing you do is you need to identify which variable you're solving for. It's time. So our equation has to have time in it. Now velocity and distance doesn't have it, so we're not going to use this one. It's either uniform acceleration or velocity. Now do we have final velocity? No, right? Because it's at the bottom. We're going to find it for question B, but we don't have it yet. So we have to use uniform acceleration. So x equals x naught plus v naught t plus 1/2 at squared. We need to rewrite this in terms of delta x. We know delta x is x minus x naught, so we just move x naught to the left side, which is the same as subtracting. So, wait, before. I'm getting ahead of myself, so x minus x naught, this cancels, is equal to v naught t plus 1/2 a t squared. Now let's rewrite this in terms of delta x. V naught t plus 1/2 a t squared. Now we know that the initial velocity is 0, so this whole term, v naught t, is going to cancel. It'll go to 0. So we have delta x is equal to 1/2 a t squared. Now we just have to solve for t because we're looking for time. So at the end, our equation should say t is equal to, and then some other stuff. Let's get rid of the fraction. You multiply by the reciprocal. 2 divided by 1 is 2, so you want to make sure you do it on both sides. This cancels. Twice the displacement is equal to acceleration times time squared. I'm going to rewrite this so that t is on my left side. So a t squared is equal to twice delta x. I need t by itself, so let's divide by a. This cancels. T squared is equal to twice the displacement divided by the acceleration. To get rid of a square, we'll just do a square root. And our equation will look like this. 2 delta x divided by a. And then don't forget this is square root. Now we just substitute 2 delta x. We know it's 410 meters. Don't forget about the units. And then divided by the acceleration due to gravity, which is 9.8 meters per second squared. And this is, let me redo this line. Square root. And you'll see that your time is, so let's do that real quick. 820, no, 29.8. We take the square root, 9.14 seconds. 9.14. Let me rewrite that. Looks kind of ugly. Looks the same now, but so this is our time. We box it. So now we have found the time. So that's question A, right? Now we go on question B. For question B, we're looking for with what velocity. So that means at the hit the ground, so down here. So if this is initial, then we're looking for velocity final. So now, so if we add velocity final equals question mark, then which one do we need? We want velocity final, we have acceleration and time. So we can simply use the velocity one over here because we want velocity by itself, just v, look. So we have velocity is equal to velocity initial plus acceleration multiplied by time. We know that the initial velocity is 0 because it started from rest, so we cross that out. Acceleration multiplied by time. So we just substitute. Acceleration due to gravity is 9.8 meters per second squared times the time, which is 9.14 seconds. And we get that our final velocity, let's do it one more time. I erased it. .57 meters per second. This is our final velocity when it hits the ground, right before it hits the ground. So just make sure you do the drawing, list all the information given, look at what you have, what you need to solve, make sure you have only one unknown on the equation that you pick, do some algebra, solve for the correct variable, and substitute. Bye guys.